Hitler had a secret weapon that nearly starved Britain out of the war, but he made one fatal miscalculation about American ingenuity. It wasn't the U-boats that almost won the Battle of the Atlantic. It was an invisible weapon, a silent killer, and the Nazis thought it was unbeatable, until it wasn't. You might remember the Liberty ships, but few remember the invisible terror that sunk them by the dozens and the brilliant, simple fix that saved the war. It was the autumn of 1939. In the United States, most folks were still trying to shake off the last chill of the Great Depression. They were listening to Glenn Miller's Moonlight Serenade, perhaps looking forward to the picture show on Saturday. The war in Europe, the one that had kicked off in September with the invasion of Poland, still felt a long, long way away, a problem for another continent. But across the Atlantic, in Great Britain, the situation was already becoming desperate. They called it the phony war on land, as armies stared at each other across the French border. But at sea, there was nothing phony about it. The Battle of the Atlantic had begun, and it had begun with a terrifying, vicious ferocity. Now, we've all seen the movies, we've read the books, we know about the U-boat wolf packs, those iron coffins, as the German crews called them, stalking the convoys in the blackness of the North Atlantic. That was a fight we understood. A submarine fires a torpedo, a ship sinks. It's brutal, it's horrifying, but it makes a certain kind of terrible sense. But this was something else entirely. This was a new kind of terror. In the Thames estuary, the vital waterway leading to the docks of London, ships were simply vanishing. One moment, a coastal steamer, the SS Magnapur, is chugging along in a channel that had been swept for submarines just hours before. The water is calm. The next, a colossal pillar of water, mud, and fire erupts from beneath her keel, lifting the ship clear out of the sea before breaking her in two. She was gone in less than 90 seconds. There was no torpedo wake, no lookout had cried periscope. No one heard the drone of a bomber overhead. Just oblivion. The few sailors who survived, pulled choking and shivering from the oily cold water, all told the same story. There was nothing there. This wasn't just a random tragic accident, because it happened again and again. The City of London, the SS Hookwood, the list grew longer every day. Big ships, small ships, warships, all exploding in channels that were supposed to be safe. This was terror of a different kind. It was invisible, it was silent, and to the men experiencing it, it felt almost supernatural. In London, at the Admiralty, the mood was darker than the mandatory blackout curtains that covered every window. The First Lord of the Admiralty, a familiar name to us all, Winston Churchill, was a man not known for his patience. He was furious. He slammed his fist on the great oak table in his office, demanding answers. The U-boat was a shark, and he knew how to hunt sharks. But this was a disease, a plague that was choking the lifeblood of Britain, and he had no cure. If this continued, Britain would starve. It was that simple. An island nation, it depended on the sea for everything, for food, for fuel, for steel, for bullets. If the ships stopped, the war was over, and the Nazis knew it. Then, on the 23rd of November 1939, they got the break they were desperate for. A Heinkel bomber, flying low in the fog over the mudflats at Shoeburyness, was seen by observers on the shore. It dropped a large, cylindrical object attached to a parachute. It didn't explode. It landed softly in the shallow, muddy water just offshore. The tide went out, and there it was, a sleek, dark shape, resting on the mud like a beached whale. This was a moment of incredible bravery. Two officers, Lieutenant Commander John Overy and Roger Lewis, walked out to it. They knew it could be booby-trapped. They knew it could be designed to explode if it was moved or if the light hit it. They knew it could be listening for the tiny amount of steel in their helmets or the buttons on their coats. They spent hours hours in the freezing, wet mud, the winter wind whipping across the flat. They meticulously photographed it. They measured it. And with hands that must have been shaking, but a resolve that was pure steel, they began to disarm it. They were working with tools made of non-magnetic brass. Their hands were numb. Every turn of a screw was a gamble with their own lives. But they did it. They found the trigger. It wasn't a contact fuse. It wasn't a timer. It was a delicate, precise instrument, a delicate needle, balanced perfectly, just like in a compass. A needle that would dip and close a circuit, detonating 2,000 pounds of high explosive when, and only when, it sensed a large magnetic object passing over it. The signal was the ship itself. They had it. The magnet mine. The Type GA magnetic influence mine. This was the weapon the Nazis had been seeding in Britain's harbors by submarine and aircraft. This was the weapon they were counting on to starve the island into submission. And it was a brilliant, devilish piece of engineering. The Nazi High Command, particularly Admiral Raeder and Karl Donitz, head of the U-boat fleet, were supremely confident. They saw this as the perfect weapon, the ideal partner to their submarines. Why? Because the mine was cheap to make. You could drop it from a plane, sow an entire harbor in a single night. And it was, they believed, completely impossible to sweep using traditional methods. Think about it. A minesweeper, the kind we'd used since the First World War, worked by dragging a heavy cable through the water, a cable designed to cut the tethers of floating mines, bringing them to the surface to be shot and destroyed. But these new horrors sat on the seabed. You couldn't cut them. You couldn't see them. You couldn't snag them. And every single ship the Allies had, from the magnificent Queen Mary down to the smallest fishing tug, was made of steel. Every one of them, whether they knew it or not, was a giant floating magnet. The Nazis believed they had created a problem that had no practical solution. They had dismissed any possibility of a countermeasure because how do you hide a 10,000-ton steel ship from a magnet? The tonnage war was on, and the Nazis were winning. They were certain that British and later American ingenuity had no answer. They had, in effect, dismissed any attempt at jamming their perfect signal, because the signal was physics itself. They were wrong. And that arrogance, that failure of imagination, would cost them dearly. Back in Britain, with the disarmed mine now in a laboratory, the mood was one of part terror, part relief. They now knew what was killing them, but the how to stop it was still a terrifying blank. The first attempts were frantic, almost comical in their desperation. They knew the mine was triggered by magnetism, so how do you trigger the mine safely? The first idea was to take a wooden ship, a trawler, and load it with a gigantic magnet, a massive electromagnet salvaged from a junkyard crane, and power it with a diesel generator bolted to the deck. The idea was to sail this contraption over the minefields, turn on the magnet, and shout a huge magnetic pulse into the water, fooling the mines into exploding. They called this the LL sweep. It was dangerous, clumsy work, but it was all they had. At the same time, another idea was being floated. What if instead of trying to sweep the mines, you tried to make the ships invisible to them? This is where a man named Charles F. Goodeve enters the story. He was a Canadian, a brilliant physicist, a professor in London. He wasn't a sailor, he was a scientist. And he was brought into the Admiralty to look at this problem not as a naval officer, but as a physicist. Goodeve and his team of scientists, they were called the Saturday Scientists because they all had day jobs as professors, locked themselves in a room and went back to first principles. They asked the most basic question: why is a ship magnetic? Most of us probably don't think about it. Steel is steel. It sticks to a magnet. But a ship isn't just a lump of steel. It's a massive, structured lump of steel. And it's been sitting in a shipyard for months, being hammered and riveted, all while sitting inside the Earth's own magnetic field. Goodeve explained it simply. The Earth itself is a giant magnet. We all know that. It's why a compass points north. When you build a giant steel box, like the ship's hull, in that magnetic field,
The Earth's magnetism induces a field in the ship. The steel plates, the rivets, the keel, they all line up, magnetically speaking. By the time the ship is launched, it is no longer just a pile of steel. It is one single enormous floating magnet with its own north and south pole. This permanent magnetism was bad enough. But there was a second, even trickier problem: the ship's induced magnetism. This was the magnetism that changed depending where the ship was and what direction it was pointing. A ship sailing north would concentrate the Earth's magnetic field in a different way than a ship sailing east. A ship in the North Atlantic would have a different magnetic color than a ship near the equator. The Nazi mind was sensitive enough to pick up this signal, this magnetic signature. The ship was literally broadcasting its presence to the seabed. So WWII asked the next logical question. If the ship is a magnet, can we simply turn it off? It sounded like science fiction, but it was based on physics that was already 100 years old. The man it was named after, Carl Friedrich Gauss, was a German mathematical genius from the 19th century. And now, his own country's greatest weapon was about to be defeated by his own discovery. The idea was this: if the ship's hull has a magnetic field pointing, say, north, what if we wrapped the entire ship in a giant coil of wire? And then what if we ran a current through that wire? We all learned it in school. Running a current through a coil creates an electromagnet. What if you could tune that electromagnet perfectly to create a field that was the exact opposite of the ship's own field? A south field to cancel out the north field. From the mind's perspective, on the seabed, the ship would have no magnetic signal at all. It would be invisible. It would be a ghost ship. This was the theory. They called it De-Gaussing. Now they had to see if it would work. The urgency was absolute. Every day more ships were being lost. They requisitioned a ship, the HMS Borealis, and brought it to a dockyard. Teams of men working around the clock began the massive, grueling task of wrapping this entire vessel from bow to stern in hundreds of turns of thick, insulated copper cable. They were inventing the process as they went. They bolted wooden battens to the hull, they strung the cable, they waterproofed the connections, they ran the leads up to the bridge to a control panel that was, at first, little more than a rheostat, a dial to control the electricity.
They finished. They powered up the generator, and they sailed the Borealis out over a channel they knew was full of German magnetic mines. The crew on that ship, you have to pause and think about the courage that took. They were sailing on a prayer, a theory from a professor. They were the bait, and they knew it. They sailed over the first mine's suspected position, nothing. They sailed over the second, silence. They crossed the entire minefield, and they came back. It had worked. The theory was sound. Charles WWII and his Saturday scientists had found the answer. They had found the jamming technique that the Nazis had thought impossible. The celebration was short-lived, because now they had a new problem, a problem of scale. It was one thing to wrap a single dedicated ship in a dockyard. It was another thing entirely to apply this to every single ship in the Royal Navy and the entire British Merchant Marine. We're talking thousands of ships, from the HMS Hood, the pride of the fleet, to the smallest, dirtiest coal freighter. And they had to do it now. A frantic, nationwide effort began. It was a logistical nightmare. They called it simply the coiling. Shipyards became madhouses. Teams of electricians and dock workers, many of whom had never handled this kind of equipment, were given crash courses. They were crawling over holes, day and night, in the rain, in the blackout, wrapping. They requisitioned every foot of copper cable in the United Kingdom. They ran out. They started using aluminum. They ran out of that. They even, in some cases, used strips of steel. They also developed a faster, cruder method for ships that couldn't wait. They called it wiping. They would bring a ship into a berth and essentially flash it with a massive jolt of electricity from a fixed cable, temporarily scrambling its magnetic signature, confusing it. It wasn't permanent,
but it might last a few weeks. It might be enough to get a convoy out of the danger zone. But the coils were the real answer, and they had to be tuned. This wasn't a one-size-fits-all solution. Every ship was different, and, as Goodeve had predicted, a ship's magnetism changed with its latitude. So they had to invent another new thing, the De-Gaussing range. They would set up incredibly sensitive magnetic detectors, magnetometers, on the seabed at the entrance to a harbor like Portsmouth or Liverpool. A newly coiled ship would have to sail slowly over this range. A technician on shore, often a member of the Women's Royal Naval Service, the Wrens, would be watching the needles on their instruments. They would radio the ship. "You're hot in the bow. Dial up the M coil circuit 5. The electrician on the ship would crank the dial. "Okay, that's better. Now you're showing a bit of a list to port. Adjust the F coil." They were tuning the ship, like tuning a giant floating guitar. They were neutralizing its signature inch by inch until the needles on the shore station's panel barely flickered. Only then was the ship wiped and declared safe to sail. It was an incredible, improvised, brilliant system. And the effect was immediate. The rate of sinkings from magnetic mines plummeted. Ships that, a month before, would have been guaranteed to detonate a mine, now sailed harmlessly over them. In the German High Command, there was confusion, then disbelief, then fury. Their unbeatable weapon was suddenly not working. Their intelligence reports were contradictory. They couldn't believe the British had managed to equip their entire merchant fleet with such a complex scientific defense in a matter of months. It seemed impossible. They had fatally underestimated the desperation and the ingenuity of an island nation fighting for its very life. This victory, this incredible scientific achievement, was one of the most important and least known turning points of the early war. It saved Button. But the war was just getting started, and across the Atlantic, America was stirring. December 7th, 1941, a date which will live in infamy. The attack on Pearl Harbor thrust America into the war, a war it was not yet ready for, but one it would have to win. Suddenly, the problem wasn't just about saving Britain, it was about supplying the entire Allied war effort, in Britain, in Russia, and soon in North Africa and France. The United States would have to become, as President Roosevelt called it, the arsenal of democracy. And that arsenal would be carried on the backs of ships. This brings us to one of the enduring symbols of American industrial power, the Liberty ship. This wasn't a pretty ship. It wasn't fast. It wasn't heavily armed. In fact, it was based on an old, simple British design for a freighter. But it had one overwhelming virtue. We could build them. We could build them faster than anyone had ever dreamed possible. The man who spearheaded this effort was Henry J. Kaiser. He wasn't a shipbuilder. He was a construction mogul, a man who had built dams and bridges. He looked at shipbuilding not as a delicate art, but as a massive construction project.
He threw out the old rule book. Traditionally, you built a ship from the keel up, right there on the slipway. It took months, sometimes a year. Kaiser said, no, we're going to build it in pieces. We'll have one factory build the engine. Another will build the prefabricated deck houses. Another will weld the great hull sections. And then, at the shipyard, we'll just put it all together, like a giant model kit. And he preferred welding to riveting. Riveting was slow. It took skilled crews. Welding was fast. It was strong. And it's what gives those Liberty ships their smooth, strangely modern look. The results were staggering. At the start of the program, it took about 230 days to build one Liberty ship. By the end of the war, Kaiser's yards in Richmond, California and Portland, Oregon were churning them out in an average of 42 days. One ship, the SS Robert E. Peary, was built as a publicity stunt, from the first plate laid to launch in 4 days and 15 hours. It was a miracle of mass production. We built 2,710 of them, a bridge of steel, an endless conveyor belt crossing the Atlantic and the Pacific.
But here's the problem. The green problem. What is a Liberty ship? It's a 10,000-ton box of welded steel, built at incredible speed, all identical. From the perspective of a German magnetic mine, the Liberty ship was the most perfect, delicious, irresistible target ever created. They were, magnetically speaking, screamingly loud. The Nazis knew this. By this time, they were well aware of the British de-Gaussing efforts. But again, they fell into their old trap: arrogance. They looked at the scale of the American shipbuilding program and they did the math. They concluded that the Americans could never implement a complex, sensitive, scientific fix like de-Gaussing on that many ships. It was too finicky. It was too slow. It required trained physicists. They believed that even if we built the ships, their mines and U-boats would sink them faster than we could replace them. They believed the tonnage war was still winnable. They had dismissed the signal jamming technology, not because it didn't work, but because they believed it couldn't be industrialized. And this was perhaps their single greatest misunderstanding of the American character, because the Americans didn't just use de-Gaussing, they mass-produced it. The U.S. Navy, working with the original British research, didn't treat de-Gaussing as a complicated afterthought, a modification to be done in a special lab. They treated it as just another part of the assembly line. When a Liberty ship is being built, when those great prefabricated sections were being welded together, the de-Gaussing coils were installed right along with the plumbing and the electrical wiring. It was built in. Every single Liberty ship that came off the line already had its de-Gaussing girdle installed. And the process of tuning the ships was also put on an industrial scale. In major ports like Norfolk, Virginia, or New York Harbor, or San Francisco Bay, the Navy established de-Gaussing ranges. These weren't just one-off labs. These were drive-through stations. A brand new Liberty ship, fresh from the yard, loaded with tanks and ammunition for its maiden voyage, would first have to stop at the range. It would sail over the series of underwater magnetometers. In a small shed on shore, a sailor, very often a member of the Waves, the women accepted for volunteer emergency service, would be watching the panel of needles. These women were highly trained technicians. They became some of the world's foremost experts in applied magnetism. They would get on the radio to the ship's captain. "Okay, Captain, bring her over, steady as she goes." The needles would jump. "All right, she's running hot, very hot. Tell your electrician to energize the M coil. Give me 40 amps. On the ship, the electrician would turn the great brass wheel on the control panel. "Better," the Wave would say. "That's better. Now she's showing a strong signature on the port quarter. Let's have 20 amps on the FQ coil. That's the fore and aft and athwart ship combination." This would go on for an hour, a delicate, precise conversation. They were tuning the 10,000-ton ship, dialing in the currents, balancing the opposing fields, until the ship's magnetic signature was so faint, so quiet, that the needles on the shore panel barely trembled. "She's neutral," the Wave would finally say. "Signature is flat. You are clear to proceed, Captain. Good luck and good hunting." And that ship, that giant, lumbering, vital Liberty ship, would sail out of the harbor. It would sail right over minefields laid by German U-boats at the harbor mouth, and the mines would hear nothing. They would sleep silently on the seabed as tons of American steel, tanks, bullets, and food sailed harmlessly, invisibly, right over their heads. It was an absolute, unmitigated triumph of science and industry working together.
We're going to pull apart more of this hidden chapter of history, and if you appreciate these kinds of stories, the ones that happened just behind the main headlines, the ones that truly made the difference, you might consider subscribing. We specialize in them here. We believe the men and women who solve these problems deserve to be remembered, and we do our best to honor them. Now, you might be thinking, couldn't the Nazis just build a better mine? Well, that's the logical next question. And the answer is yes, they did. The war at sea was a constant, desperate game of cat and mouse.
When the Nazis realized their magnetic mines were being defeated, they didn't just give up, they adapted. If the Allies could hide the ship's magnetism, they reasoned, they would build a mine that listened for something else. So, they developed the acoustic mine. This was, if anything, even more devilish. It sat on the seabed just like the magnetic mine, but its trigger wasn't a balanced needle. It was a microphone. A hydrophone, to be precise. It was listening for the one sound that every ship makes, the thrum, thrum, thrum of its propellers. When a ship passed overhead, the vibration, the specific frequency of its turning screws would shake the microphone, close the circuit, and detonate the mine. For a time, these new mines caused havoc all over again. The nightmare had returned. Ships that were perfectly de-Gaussed, that were completely ghosts to the magnetic mines, were suddenly being blown up by these new acoustic ones. The scientists at the Admiralty and the U.S. Navy had to go back to the drawing board. Their solution was once again brilliantly simple. If the mine is listening for a sound, let's just make a lot of noise. They developed a device called the Foxer. It was, essentially, a set of noise-making bars, like giant metal rattles that a ship would tow on a long cable 500 yards behind it. These bars were designed to vibrate and bang together in the ship's wake, creating a racket that was far louder than the ship's own propellers. The acoustic mine, hearing this tremendous noise approaching, would detonate harmlessly, 500 yards behind the ship, sending up a great plume of water but doing no damage. It was another countermeasure, another victory for the boffins, as the British called their scientists. But the Germans were not done. They were brilliant and they were ruthless. They came up with their final and most terrible mine, the pressure mine. This one was truly a nightmare. It had no magnet, it had no microphone. It had a simple, delicate diaphragm that measured the pressure of the water above it. When a 10,000-ton ship sails through the water, it doesn't just float on top, it displaces that water. It creates a tiny, almost undetectable wave of pressure beneath it. As the ship passes over the mine, the water pressure on the seabed increases by a minuscule amount, just a few pounds per square inch. The mine was designed to feel this, to feel the shadow of the ship passing over it. And this was a problem that De-Gaussing couldn't solve. This was a problem that a noisemaker couldn't fool. How do you hide the weight of a ship? How do you jam a signal that is a fundamental law of physics, the law of displacement? This mine was so sensitive, it was rumored that even a large whale could set one off. And they were almost impossible to sweep. You couldn't fool them with a magnet. You couldn't fool them with noise. The only way to clear them was to find them, one by one, with divers, or, in a much more desperate measure, to simply drop bombs in the harbor, hoping the shock waves would detonate any pressure mines nearby. This was slow, and it was terribly inefficient. Many ships were lost to these pressure mines right up to the end of the war. But by the time the pressure mines were being deployed in large numbers, it was 1944. The tide had already turned. The D-Day landings had been successful. The Great Bridge of Liberty ships, protected by De-Gaussing, had already delivered the men and the material that would ensure victory. The pressure mine was a brilliant, deadly invention, but it had come too late. The signal jamming that the Nazis had dismissed in 1940, the simple coil of wire wrapped around a steel hull, had already done its job. It had kept the lifeline open during the most critical years of the war. So what is the legacy of this incredible, forgotten piece of technology? Well, if you go to a naval port today, if you see a modern Arleigh Burke destroyer or an aircraft carrier like the USS Gerald R. Ford, you might not see it, but it's there.
Every single major naval vessel built today, and even many large commercial ships, has a de-Gaussing system built in. They're no longer the clumsy, heavy cables bolted to the outside of the hull. They are sophisticated, computer-controlled coils built inside the ship's structure. Modern ships still go to de-Gaussing ranges. They still sail over sensors. But now, instead of a wren on a radio, a computer automatically adjusts the currents in dozens of different coils, blanketing the ship in a perfectly tuned counterfield, making it invisible to modern, highly sensitive magnetic influence mines that are still a threat in waterways around the world. This technology, born of desperation in a London lab in 1939, is still protecting sailors today. It is one of the great unsung victories of the Second World War. And it's a powerful reminder of a simple truth. The war wasn't just won by soldiers with rifles or pilots in Spitfires. It was won by men and women in labs. It was won by professors who knew their 19th century physics. It was won by dock workers who toiled in the blackout wrapping cables. It was won by those waves in their quiet sheds on the shore, patiently tuning the great ships. And, most of all, it was won by the courage of the merchant mariners. Those men, often too old or too young for the regular Navy, who sailed those Liberty ships. They were civilians, technically, but they faced a casualty rate higher than almost any branch of the armed services. They sailed into waters they knew were infested with U-boats and mines, trusting that the scientists and engineers had gotten it right. Trusting that that simple wire, that magic girdle around their hull, would keep them safe from the invisible death that waited on the ocean floor. It's a staggering thought, isn't it? If you've ever known anyone who served in the Merchant Marines, or perhaps served yourself in any capacity, you understand what that kind of quiet, professional courage means. So many of us have a connection to that generation. Let us know in the comments. We truly value hearing those first-hand perspectives and honoring that service. When we look back at the story of the Liberty ships, we often focus on the welding, the speed, the sheer industrial might. But the true miracle wasn't just that we built them. The true miracle was that we kept them safe. The Nazi high command made a critical error. They dismissed a technology because they couldn't imagine it being implemented on a grand scale. They understood the science of their weapon, but they failed to understand the resolve of their enemy. They failed to understand that when faced with an existential threat, a free people can innovate, adapt, and industrialize a solution at a speed that seems impossible. They believed their signal was unbeatable. But a handful of scientists and an army of unknown workers found a way to jam it. Not with a loud burst of static, but with a quiet, elegant, and invisible shield of pure physics. They didn't just counter the weapon, they made the target disappear. And that made all the difference. This story is just one of many, just one of the countless innovations and sacrifices that led to victory. If you'd like to see more about the hidden technologies and the unsung heroes that changed the world, please click the like button. It's the simplest, no-cost way to tell us we're on the right track, and it helps these stories reach more people. We hope you found this piece of history as fascinating as we do. It's a testament to the idea that sometimes the biggest victories aren't won with the loudest bang, but with the quietest signal. Thank you for lending us your time. We appreciate it.